Hello Chem 1A, this is Chapter 3, Lecture Video 8, and we're going to continue kind of doing some sample problems with mass, moles, and atoms, i.e. molar mass and Avogadro's number. And then we'll talk about percent composition. So maybe we have another problem, like what is the mass of 7.83 times 10 to the 23 molecules of water? So in this problem, we have 7.83 times 10 to the 23 molecules of H2O. And we want grams. So the first thing we need to do is we need to go from molecules to moles using Avogadro's number. So 6.022 times 10 to the 23 molecules of H2O are in 1 mole of H2O molecules. Then we have to use the molar mass of H2O. 1 mole of H2O is 18.02 grams of water. And if we follow along at this point, right, molecules of water have canceled, moles of water have canceled, and we're left with grams of water, which is what we were asked for in the problem. This gives me approximately 23.4 grams of water. All right, so let's do one more. I'm just trying to erase that so that I can get some more room here. What is the molar mass of element X if 45.6 grams of X3O4 contains this many atoms of oxygen? So this is probably one of the harder problems we could see. So right now we know that the molar mass of X is what we want, right? So we want molar mass of element X. And we know that in 45.6 grams of this compound, we have this many atoms of oxygen. Now, that's helpful. If we want the molar mass of X, we need to calculate grams of X over moles of X. So I need these two values. Now, let's start with moles of X. I know that 5.194 times 10 to the 23 atoms of O are present. And I can divide by 0.0622 times 10 to the 23 atoms of O per mole of O. After that, I can get moles of O down here, and I can go to moles of X up top. And I can use these values in the formula to do this, right? I know for every 4 moles of oxygen, there are 3 moles of X in this compound. So here we can see that my atoms have canceled, my moles of oxygen have canceled, and I've been left with moles of X, which is one of the values I need to calculate my molar mass. I get that there's 0.647 moles of X in this mass of 45.6 grams. Now the problem is I need grams of X, but I don't have it. I have grams of the compound, not of X individually. So I need to find a way to get just grams of X. Now, if I had grams of oxygen, I know the mass of oxygen plus the mass of X have to add up to 45.6 grams because of the law of conservation of mass. So I need to figure out how many grams of oxygen there are in this compound. Now, going back to this segment, right, we know 5.194 times 10 to the 23 atoms of oxygen are present. And I can use Avogadro's number, 6.022 times 10 to the 23 atoms of O in 1 mole of O. And I know that the molar mass of oxygen is 16 grams per 1 mole of oxygen. So this will allow me to cancel atoms, cancel moles, get grams of oxygen, which will allow me to calculate grams of X. I get that there are 13.8 grams of O. Now, if I take 45.6 grams of X3O4 and subtract 13.8 grams of oxygen, I get how many grams of X there are in this compound. And there are 31.8 grams of X. Finally, now I can calculate my molar mass of X. I already calculated moles of X. That we have here. And now I got grams of X, so I just need to divide these two values. 31.8 grams of X per 0.647 moles of X. And if we divide that out, I get my molar mass, which is 49.15 grams per mole. Okay, so let's do another problem. How many oxygen atoms are there in 23 grams of calcium hydroxide? So the first step here is going to be writing out the formula of calcium hydroxide, which will be this. Because calcium has a 2+ charge, hydroxide has a -1 charge, and we have 23 grams of this. So 23 grams of CaOH2. I need to next calculate the molar mass of calcium hydroxide. It ends up being about 74.1 grams of CaOH2 per 1 mole of calcium hydroxide. All right, so I want to know how many oxygen atoms there are. So the next step is to go from moles of calcium hydroxide to moles of O. And because there's this 2 here on the outside of the exponents, we know every 1 calcium hydroxide contains 2 oxygens. Lastly, I just need to use Avogadro's number, 6.022 times 10 to the 23 atoms of O in 1 mole of O to get my number of atoms of oxygen in this compound. This will get me 3.74 times 10 to the 23 atoms of oxygen. All right. So the last problem here is how many grams of chromium are there in 35.6 grams of chromium 3 sulfate. Again, first step, writing the formula of chromium 3 sulfate, which is this. Then I'm going to need the molar mass of it. And from there, we can do some mole ratios and stuff to get how many grams of chromium there will be. Now, I can tell you because of the law of conservation of mass, our mass of chromium has to end up being less than 35.6. So we have 35.6 grams of Cr2SO4 Let's divide by the molar mass to get moles. Our molar mass of this compound is 392.21 grams of Cr2SO4 per 1 mole of Cr2SO4. Next, we got to do a mole ratio. We know that in 1 mole of chromium 3 sulfate, there are 2 moles of chromium, again because there are 2 chromiums in the compound. Next, to get grams, we just need to multiply by the molar mass of chromium, which is 52 grams of chromium in 1 mole of chromium. All right, so if we hit equals here, we can get our mass. And we get that there are 9.44 grams of chromium in this sample. All right, so let's move on. Let's talk about percent composition. Percent composition is a type of analysis, or generally a percentage of one element in a compound by mass. Now, a number of different types of instruments give out this as an analysis of a substance. So if we have an unknown substance, we can run it through, for instance, a mass spectrometer. And usually what will come out of that will be a percent composition analysis of every element in the compound. So how do we calculate percent composition? Well, it's just simply the number of elements times the molar mass of the element you want to calculate percent composition in the compound for, divided by the molar mass of the compound times 100 to get to percentage. So this is not an equation I give you. You should know how to use this equation. Let's do an example problem and work it out. So we want to know what is the percent composition of oxygen in potassium phosphate. So first step, write the formula. Potassium phosphate is K3PO4. Next, we're going to need the molar mass of this compound. So let's calculate that. The molar mass should be 212.27 grams per mole. Okay, so if we want this for oxygen, we're going to go, okay, well, how many oxygens are there in the compound? Well, there are 4 oxygens in the compound. What's the molar mass of oxygen? 16 grams per mole. And we know the molar mass of the compound is 212.27 grams per mole. Well, now we just multiply this by 100, and that'll get us our percent composition of oxygen in potassium phosphate. This will be 30.15%. Okay, so let's do this again, but now we'll do potassium. There's really not much of a difference here. Now we're just going to do this for potassium in the numerator. The denominators are going to stay the same, so we still have 212.27 as our molar mass of the compound because we're still dealing with potassium phosphate. So we know there are 3 potassiums, and the molar mass of potassium we can look up. It's 310.10. And if we multiply that by 100, we can get our percent composition of potassium. We get the percent composition should be around 55.26%. All right, so now for the last one, we can do this 2 different ways. We can use the same formula that we've been using to calculate percent composition for phosphorus, or since we know there are only 3 elements, oxygen, phosphorus, and potassium, we can actually just add these 2 percent compositions we've already calculated and subtract from 100 to get phosphorus's percent composition. 100 minus 30.15 minus 55.26 will also give us our percent composition of phosphorus. Choose whichever way you want to do it. It doesn't really matter. I'm going to do it this way just to kind of show the option. You should get that phosphorus is about 14.59% of the compound by mass. All right, so if you have any questions about percent composition or mole to gram to particle calculations, please let me know.